The next topic is analog multiplexer. You know that multiplexers are those devices which are generally employed in order to select a single channel from multiple channels, isn't it? So, in analog circuits also, we do have multiplexers where, let us suppose it is just like you do have multiple signals coming in this one. You need to select only one. So what I'll use is nothing but I'll use, right. So it is just like selecting one of the channels for your output. So this device, the device which performs these type of function is called as multiplexer. And since it is used for analog signals, I'm calling it as analog multiplexer. So see, it selects a signal from one of the several input channels and it transfers the selected signal to its output channel, thereby permitting the transmission of several signals in a serial manner. So at time is equal to 0, I will select this signal, and after some time I will select this, after some time I will select this. So multiple signals are there. You may be having a sequential process of selecting the signals, one signal at a time. So that job can be performed by an analog multiplexer, because in power systems you will be having multiple data, right? Currents will be there, voltage will be there, frequencies will be there. Maybe you are ready to perform only one particular operation at a time. So you want only one particular signal. So maybe you will be getting is a voltage signal here, current signal, frequency signal, or I1, I2 from different locations. So at any one point of time, you want to concentrate only on one signal. So which signal you want to do? So that job is done by analog multiplexer. Okay. So normally we do employ multi-terminal rotary switches. If it is a solid state multiplexer, we do employ multi-terminal rotary switches. So this is a multi-terminal rotary switch. I will show you the figure. Yeah, this is a multi-terminal rotary switch. Right? See, if you carefully see, there is a serial output, and these are the inputs, different inputs, and you are choosing them one at a time. Now, see, this is your multiple data inputs, and this is a switch, a rotary switch. Based upon that, you will be selecting a output. Now, let me get back to you once again. So how is analog multiplexing basically achieved? So analog multiplexing is normally achieved in two ways. One is by frequency division multiplexing. You might have studied this in your signals and systems, but a quick review: frequency division multiplexing, FDM. This is one mechanism which you generally employ for your. It is just like your what I can say. It is just like a TV, right? For my TV, for my television set, basically I'll be having a single wire where it attracts so many number of signals, right? I mean to say, Sun TV is there, Star Plus is there, Hotstar is there, and Sony. So many channels are coming to my system, to my TV, but there is only one wire. So how you are selecting? So you are selecting based upon the frequency. So many channels are available for you out in the air, but among those, you are selecting one particular frequency, and that is being transmitted to your screen. So this is called as frequency division multiplexing, right? So you are selecting based upon the frequency. This is one mechanism. And the other one is amplitude division multiplexing, or sorry, it's not man, it's wavelength. Wavelength division multiplexing. Yeah. What I call it as WB wavelength. It is just like having signals of multiple wavelengths, and your optical fiber. Have you ever heard about this optical fiber? For optical fiber, you will be transmitting signals of different wavelengths, and you are trying to project it as a single line. So, and you will be selecting the signals based upon the wavelength. So it is just like you having multiple signals, and you are selecting one among them based upon your requirement. Either analog multiplexers, they do employ either based upon the frequency or based upon the wavelength. Okay, so filters and multiplexers, these two are also part of your primary subsystem, which we have seen in the components of digital relay. Okay, the signal conditioning subsystem. Now, I hope that now you have understood why we do require LP filters as part of digital relays, because they reduce the noise in the signals, while analog multiplexers, they help in selection of the signals. So it's your choice how to select an LP filter and also the mechanism of analog multiplexer. Okay, so I hope that now you are able to describe the operation of analog filters and analog multiplexers and their requirements in digital relays. And I hope that you can answer this question in detail. Okay, thank you.